Hola. So today we are going to be talking about below slab moisture protection. Installing a vapor barrier to prevent water vapor, liquid water, and gas from the soil moving into the building.
Yo voy a traducirlo. Hoy día vamos a presentar sistemas de transferencia de carga, principalmente de distintos tipos de gases, de transferencia de retardadores y barreras de vapor, principalmente de gases y humedad.
So this is an outline of the presentation really quick. We're going to go over the problems that humidity and gas can cause in the building envelope and with the concrete as well. Then we're going to talk about the science of how moisture and gas moves into the building. And then we're going to talk about some new standards that exist in the United States to prevent these problems from occurring.
Vamos a hablar de problemas comunes de humedad y gas que se producen dentro de los edificios y cómo funciona la ciencia de la migración de la humedad en los edificios y también, para terminar, los nuevos estándares que se usan en Estados Unidos.
So here's all the problems that can exist. I'm going to go over each one of them in greater detail.
Aquí están algunos de los problemas que existen. Vamos a ir poco a poco detallándolos a lo largo de la presentación.
So the first one, floor covering failures. When moisture gets trapped beneath the flooring application, whether it's vinyl composite VCT tile, whether it's linoleum, rubber, when moisture gets trapped beneath that flooring application, it destroys the glues, and you end up with, as you can see, bubbles forming beneath that floor covering, as well as wood floor coverings that expand and then shrink, so you get a buckle, a canyon in the middle of your hardwood floors. All flooring applications have the potential to fail. Some are more likely to fail than others.
Las fallas comunes cuando hay revestimiento sobre los pisos de hormigón se producen principalmente en los pisos de madera, vinílicos y gomas. Al estar la humedad en contacto con el adhesivo comienza a fallar, aparecen desprendimientos, englobamientos como aparecen ahí, y hongos en distintas partes del piso.
The next problem we're going to discuss is mold. There's three things that mold needs to survive. It needs food, it needs a temperature that it can survive in, and it needs moisture. In a building, you cannot eliminate the food. Mold can feed on anything. It can feed on dust. You cannot eliminate the food from the building. Temperature-wise, mold can grow in any temperature between about 40 degrees, this is in Fahrenheit, 40 degrees to about 140 degrees. It can survive in any temperature. The main point of this slide is basically our only shot at controlling mold from growing on our floor coverings or beneath our floor coverings is to eliminate the moisture from the equation. That's it. You can't control the food, you can't control the temperature, you have to get rid of the moisture.
Para que el hongo pueda vivir necesita esos tres factores: comida, temperatura y humedad. La comida es desde el polvo, o sea, cualquier cosa se alimentan. La temperatura es de 40 a 140 Fahrenheit, no alcanzo a hacer la conversión. Y lo tercero es humedad. De esas tres, lo único que tú puedes controlar es la humedad para evitar que aparezcan hongos sobre el recubrimiento o bajo el recubrimiento.
All right, curling, alabeo. I know that slab curl is a pretty big problem here in Chile because you have a lot of volcanic ash in your mix designs. A study has been done recently in the United States by Jerry Holland, Rick Smith, and that study showed that when you have a vapor barrier beneath the concrete slab, you will actually minimize slab curl long term. Initially, you might have slab curl, even possibly more slab curl, but after time, that slab will relax, and long term, you will actually have less slab curl than if you did not use a vapor barrier.
Los últimos estudios en los que ha participado Jerry Holland y Rick Smith han determinado que el uso del polietileno finalmente no aumenta el alabeo. Hay un alabeo inicial que está medido, pero después en el tiempo, al secarse la losa, y con el peso empieza a disminuirse.
All right, using a vapor barrier on industrial floors, warehouses, buildings that do not have flooring applications. The American Concrete Institute, ACI, 302 and 360, are now recommending to use a vapor barrier beneath these type of structures as well. And there's a few reasons why that is that I'm going to get into in a second.
El ACI 360 está sugiriendo hoy día usar barreras de vapor bajo los pisos de hormigón en algunas circunstancias que va a explicar ahora Jeremy.
Damaged product. What you're seeing here is moisture from the soil trying to escape into the warehouse. There is an object, a cardboard box, that is blocking airflow. It's blocking moisture from evaporating into the building, and you end up with water condensing beneath that object and damaging the box, damaging the materials inside the box. So damaged product is one reason why they recommend that.
En los pisos, en este caso en la foto podemos ver que hay cajas puestas que bloqueaban la liberación de la humedad desde la base al piso hacia adentro del edificio, y al levantarla vemos agua que comienza a dañar las cajas de cartón. Esta es una de las razones donde se recomienda el uso de barreras de vapor.
Another problem, a pretty significant one, is efflorescence. It's salt deposits on top of the concrete. As the water evaporates into the building, it brings all these high alkalinity salts to the surface of the concrete that end up just sitting there. This is a problem because it's dangerous, for one. It's extremely slippery, so if you're driving forklifts on top of efflorescence, your forklift will not be able to brake, and I've seen them slide 20 feet when they try to brake. Yeah, go ahead.
Gracias. La aparición de fluorescencia es otra de las razones. Esos minerales alcalinos vienen desde la base nuevamente y suben las sales hacia arriba, dejando el piso blanco y más resbaladizo, por lo tanto es mucho más peligroso para la operación de las grúas.
Also, so efflorescence, not only is it dangerous, but the salts absorb moisture from the atmosphere. And you can end up with what's called sweating slab syndrome. So when you have all this salt on top of the concrete surface, it's going to absorb moisture, and you can end up with, again, standing water. And if you look at those boxes, they're actually damaged, probably, a foot up the box.
Las sales en la superficie no solo son resbaladizas, sino que también atraen la humedad del ambiente. Como se puede apreciar en la foto, se comienzan a dañar las cajas o los productos que estén posados sobre el piso.
And the last problem I'm going to go over is gases. It affects the quality, the indoor air quality. Radon gas, methane gas, there's a lot of different harmful gases in the soil. Those are really the two most popular ones, I suppose, the two biggest problems. Radon is the second leading cause of lung cancer in the world. It's a pretty significant problem. So again, if you use a vapor barrier beneath that slab, it takes out all of the harmful gases from the soil and improves the indoor air quality. Oops.
Los gases es otro de los temas donde es recomendado usar las barreras. El gas radón y el gas metano son los principales dos tipos de gases que aparecen. El radón es la segunda causa de cáncer al pulmón en el mundo. Sitios contaminados con otros gases químicos también se recomienda poner la barrera para evitar que entren al edificio.
All right, so that's it with the problems. Now we're going to move on to the science of how water vapor and how gas, methane, radon, how these materials move into the building.
Esos son los problemas. Ahora vamos a explicar cuál es la ciencia que hay detrás de la entrada de esos gases al edificio.
All right, when we build a structure, put down a concrete slab on grade, a couple walls and a roof. We create a vacuum from outside to inside the building. It's taking place beneath our feet as well. It's taking place within the soil. We have higher pressure. There's high pressure in the soil beneath the concrete, low pressure inside the room. So that's what's driving radon, methane, water vapor, every kind of gas into the building.
Al tener un edificio cerrado se producen diferencias de presión en el interior del edificio con el exterior. Eso hace un efecto vacío al interior, empujando los gases desde abajo hacia adentro del edificio.
And this is just a more detailed explanation of what I just went over. The pressure in the soil, the PSI, the pressure in the soil is about 0.214. You have 100% humidity, about 50, 55 degrees Fahrenheit. You end up with 2.2 PSI in the soil. Doesn't matter if you're in Santiago, Chile, New York City, doesn't matter where you're at in the world, you end up with that pressure.
100% de humedad en la base, tienes un 0,14 de presión de PSI. Da lo mismo en qué lugar del mundo sea.
Inside the building, inside this room right now, it's probably about 7 degrees Fahrenheit, 30, 40% humidity. You end up with only 0.1 PSI in the room. So the important thing here is that you end up with twice as much pressure beneath the concrete than you have inside the building. That's what's driving, that's the vapor drive that's moving radon, methane, water vapor into the building.
En el interior del edificio tienes la mitad de presión que en la base y eso es lo que hace que los gases y el vapor entren hacia el edificio.
Okay. All right, so just going to go over some standards that have been introduced in America and in Canada as well to prevent all the problems that I just went over. So there's 2 standards I'm going to go over. Keep going. Yeah. First standard, ASTM E1745. This standard measures the puncture strength, the tensile strength, and the permeance of the plastic, of the vapor barrier.
Este estándar mide la tensión, la punción
And the permeance.
Y cuán permeable es el plástico, la barrera.
Yep, just how much water vapor is moving through the plastic sheet. So the important thing about this standard is that the 6 mil, 10 mil, 20 mil poly that you guys use on the majority of work out there and that we used in the States on the majority of everything that went down probably 10 years ago or so, that product doesn't meet this standard. It lacks the puncture, it lacks the tensile strength, and the permeance is too high. Too much moisture moves through it.
Los plásticos convencionales no cumplen con este estándar.
This slide is more detailed on what I just kind of went over. The polyethylene that is used, it deteriorates. That's one of the main reasons that it doesn't meet that standard is because it decomposes. Poly is recycled, so it decomposes. 85% to 100% of it is recycled. So when it's exposed to soil conditions and when it's exposed to concrete, it actually decomposes, it deteriorates.
Los plásticos convencionales, los polietilenos convencionales tienen un compuesto reciclado y eso hace que en el tiempo empiece a descomponerse y pierde en el fondo su capacidad de contener el vapor.
The last standard I'm going to go over really quick, it's the installation standard, and it's mostly just photos. It's the installation standard for how to install the vapor barriers.
Los estándares de instalación de las barreras de vapor, va a explicar ahora.
Basically, I mean, you might not even need to translate this part. You compact the ground.
Compactando la base.
Unroll the vapor barrier.
Desenrollando la barrera de vapor.
You want a 6-inch overlap and then tape the seams.
Hay cerca de 6 pulgadas de traslape de la barrera.
It's just showing the manufacturer's tape in the seams. We'll move on. That's
Lue-
what a job looks like when it's all completed.
Luego la sellan con un tape que también tiene condiciones de barrera de vapor.
This picture shows the strength of a product that does actually meet that standard. It's a 18,000-pound laser screed machine sitting on top of the plastic, and there's no punctures.
Ahí se ve cómo tiene la resistencia a la punción y puedes trabajar con una máquina que pesa 3 toneladas y la barrera no se rompe.
Around pipe penetrations, you're supposed to seal. This is the standard, states that you seal all the pipe penetrations with tape. You're trying to create a bathtub beneath your building, basically.
Todas las instalaciones que hayan es necesario también aislarlas con este tape de barrera de vapor.
It's just more pictures of pipe penetrations. You know, if you have a bunch of pipes in a row.
Good. We're done.
Oh, and this is just for fun here. Other uses of the product, you don't need to translate it. Cover your drawings. You can repair a hole in the back of your truck. And everyone's favorite summer activity. So, that's it. Thank you very much. Muchas gracias.